See the first question. They're talking about NaH and they're asking, this is example for which type of hydride. Options में आपको metallic hydride, electron rich hydride, saline hydride, molecular hydride ऐसा कुछ दिया है. In the notes I have already marked, they are ionic hydrides, also called as saline hydrides. एक बार यहाँ पे कुछ information mark कर लेते हैं different types of hydrides. ये जो metallic hydride है यहाँ पे मार्क करते हैं. Metallic hydride are the hydrides which are formed by elements of D and F block. Formed by elements of D and F block. Sodium जो है it belongs to S block, so it is definitely not metallic hydride. Okay. And ये जो metallic hydrides है, they are also called as interstitial hydrides. We will understand about all these things again in the chapter of hydrogen and its compounds. This question is part of hydrogen. यही information बाद में भी पढ़ेंगे, but अभी के लिए याद रखना, तब revision जैसा होगा. Metallic hydride or interstitial hydrides are formed by elements of D and F block. Saline hydrides or ionic hydrides. Saline or ionic hydrides. They are formed by S block elements. S block elements will be forming saline or ionic hydrides. So इस question में जो भी दिया है sodium hydride, it will be a saline or ionic hydride. Okay. If they ask about electron rich hydride, so पहले electron deficient. Okay. Then we can see about electron rich. Electron deficient hydrides कौन होंगे? Group 13 elements के जो भी 13 elements का hydrides जो भी रहेंगे, those are electron deficient hydrides. Examples: BH3, which exists as B2H6, AlH3. Okay, so all these are having octet incompletion. Electron deficient मतलब octet incomplete होगा. बोरॉन का outermost electrons 3 है. Those 3 electrons are forming 3 bonds with hydrogens. So आपको 6 electrons हुआ. If there are only 6 electrons, you don't have any octet completion. Hence, they are called as electron deficient hydrides. Electron rich hydrides मतलब क्या होंगे? If you are having hydrides of group 15, 16, 17. Hydrides of group 15, 16, 17. Like examples, if I take NH3. NH3 में आपको एक lone pair है. So it is an electron rich. Group 16 में से if I am taking H2O. H2O में आपको 2 lone pairs है. It is also electron rich. Group 17 में if I am taking HF, it is also an electron rich hydride. Okay. And these hydrides can also be called as molecular hydrides. ये electron rich में ही आप further category molecular hydrides के अंदर ये सब आएंगे. Electron deficient, electron rich, and you can also have exact number of electrons. मतलब if you are taking group 14 hydrides, group 14 का outermost electrons कितने रहता है? 4. If all the 4 electrons are participating in bonding, you will be getting 8 electrons. So in that case, you can take examples as CH4. Okay. So this is having exact number of electrons. It is neither electron rich nor electron deficient. Is that clear? So metallic hydrides, one of the most common questions here, which is usually asked in NEET or JEE mains. They will ask which of the following is metallic hydride, which of the following is saline or ionic hydride, which of the following is electron rich hydride, electron deficient hydride, or molecular hydride. All these, ये जो है, all these comes under covalent molecules, so they are called as molecular hydrides. Okay. ठीक है. So इस क्वेश्चन में आंसर क्या हो जाएगा फिर? NaH is
saline hydride.
Saline hydride. Exactly. Question number 16. Sodium metal on dissolution in liquid ammonia gives a deep blue solution due to the formation of. Answer?
Ammoniated
Ammoniated
electrons.
electrons.
Ammoniated electrons. वही ammoniated electron की वजह से और क्या properties आता है?
Conductivity.
Conductivity, and you also have reducing nature. As you are having an electron, it can also act as reducing agent. So you have ammoniated electrons, उसके वजह से उसका deep blue color है. When can you get this sodamide? Option C में sodamide है ना? How to get sodamide?
Hot metal.
Hot Na. If you are having a hot metal, hot Na plus NH3, you will get NaNH2. Hot Na के केस में you are supplying heat. As a result, this N bond H is broken. मेटल के अंदर से इलेक्ट्रॉन्स आएगा, N bond H ब्रेक हो गया तो H पॉजिटिव और इलेक्ट्रॉन्स कंबाइन होके will be forming H2. NH2 minus जो है it is combining with Na positive to form NaNH2 sodamide. Okay. Question number 19. The metal that forms nitride by reacting directly with N2 is lithium because of its diagonal relationship with magnesium. बाकी group 2 elements जो है all of them will be having tendency to form nitrides. Beryllium के लिए थोड़ा कम रहेगा because of its beryllium के लिए nitride formation ज्यादा ही रहेगा because small size की वजह से N3 minus को balance कर सकता है. Down the group, the ease of formation of nitrides decreases. ऐसा कुछ लिखा हमने. Okay, down the group, the ease of formation of nitrides in group 2 decreases. Remember that. What is the reason for that? Nitride being a smaller anion, it can be stabilized by smaller cation. Down the group, as the size of the cation increases, the stabilization decreases. As a result, the ease of formation of nitride decreases down the group in group 2. Okay. Question number 23. Both lithium and magnesium display several similar properties due to diagonal relationship. However, the one which is incorrect is, this is an important question. इसके बारे में हमने discuss नहीं किया. Okay. But you can get the answer based on other options. If you take option B, both form soluble bicarbonates. Agreed? The bicarbonates of lithium exist only in liquid state. Group 1 elements में lithium को छोड़ के बाकी सब being highly electropositive, they will be forming solid bicarbonates. But rest all other bicarbonates, lithium का bicarbonate और बाकी सब bicarbonates, they exist only in liquid state or in solutions. So B statement जो है वो सही है. Lithium bicarbonate exists in liquid solution. Magnesium bicarbonate also exists in liquid. So B is a true statement. They are asking about the incorrect statement. Both form nitrides. This is also a right statement. C. Both of them form nitrides. D देखो, nitrates of both lithium and magnesium yield NO2 and O2, right? उसको हीट करने से आपको ऑक्साइड NO2 और O2 मिलता है. So दोनों का हीट करने से आपको NO2 और O2 मिल रहे हैं. So first option देखते हैं. So if you eliminate the options, A option has to be the incorrect one. Let us see why is it incorrect. Both form basic carbonates. Both form basic carbonates. Li2CO3 जो है, Li2CO3, it is not a basic carbonate, but MgCO3 जो है, कल हमने डिस्कस किया है, MgCO3 is soluble in water. Remember, MgCO3 is soluble in water. CaCO3 is not so soluble. Down the group, solubility decreases because of slower decrease of lattice energy. As it is a larger anion, there will be slower decrease of lattice energy. As a result, solubility decreases. Remember that. अभी ये जो MgCO3 है, as it is soluble in water, it forms basic carbonate. मतलब क्या है? If there is limited amount of water, it forms something called basic magnesium carbonate. Limited amount of water मतलब, sorry. If you are having MgCO3, suppose to MgCO3, if it is reacting with H2O, it will form something like MgCO3 dot MgOH twice. ऐसा कुछ मिलता है. Okay. MgCO3, it will be forming, this is called as basic magnesium carbonate. If I'm having X amount of water, magnesium carbonate can dissolve in that to form MgOH twice. MgOH twice मिल जाएगा. Okay, if you are having limited amount of water, it forms a compound called, this is called as basic, because MgOH twice is base, magnesium carbonate, basic magnesium carbonate. This is not possible with lithium carbonate. आपको और एक important solubility का exception हमने discuss नहीं किया है इस block में, but we have marked that in the chapter of chemical bonding. If I take everyone, concentrate again, very very important. यहाँ पे एक पेज ऐड कर लेता हूँ और उस लास्ट में मार्क करता हूँ. If I take lithium carbonates or group 1 carbonate, Li2CO3, then you have Na2CO3, K2CO3, Rb2CO3, and CsCO3. What is the expected order of solubility? Tell me the order of solubility जो हम हमारे theory से lattice energy के हिसाब से जो मार्क करते हैं. Tell me that order.
Li2CO3 greater than Na2CO3.
Li2CO3 greater than, because down the group what is happening? The size is increasing. ये complex anion है और larger anion है. So there will be achievement of packing efficiency. Because of that, lattice energy will be decreasing at a slower rate or solubility decreases. और हम क्या कहते हैं? Li2CO3 has to be greater, 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 greater. Everyone remember, this is the expected order, but this is not the actual order in case of carbonates. हमने S ब्लॉक में ग्रुप 1 में सॉल्युबिलिटी के कहीं पे भी देखा नहीं है. सॉल्युबिलिटी के नोट्स में थर्मल स्टेबिलिटी के बारे में मार्क किया है, बट सॉल्युबिलिटी मार्क नहीं किया है. We have marked this order in the chapter of chemical bonding, so in the notes also please mark this. There is an exception in this. In this case, the solubility order becomes Li2CO3 becomes lesser than Na2CO3, lesser than K2CO3, lesser than Rb2CO3, lesser than CsCO3. Similar is the order for bicarbonates. Bicarbonates में I'm not marking here LaHCO3 because lithium bicarbonate exists only in solution ना, so इसके solubility के बारे में discuss ही नहीं करेंगे. बाकी सब bicarbonates जो है they are solids, so इसलिए इनके बारे में discuss कर रहा हूँ. Even in this case, the bicarbonates are also having solubility lesser. हम expect करेंगे greater. Very very important two orders. Okay, mark these two as separate exceptions. Exceptions in solubility of group 1 compounds. Okay, only ये दो ही exceptions है. इनके अलावा हम oxalates के लिए भी एक लिखा है. Remember, oxalates के लिए group 2 के लिए लिखा है कि only these three are exceptions in our entire chemistry for our syllabus. Okay, for our JEE NEET or JEE Advanced. So ये याद किया तो काफी है. So because of this reason, Li2CO3 is insoluble in water. If it is insoluble in water, it cannot form lithium hydroxide. Magnesium carbonate जो है वो soluble है. As a result, it is able to form basic carbonate. Lithium carbonate जो है, it is insoluble in water. As it is insoluble in water, it cannot form basic carbonate. Is that clear? Very very important question, क्योंकि बाकी सब हमने डिस्कस किया है और क्वेश्चंस के टाइम पे भी बहुत ज्यादा डिस्कशन हो रहा है. This is the point we have not discussed. And based on this, you need to also remember these orders. These are given in the chapter of chemical bonding. Okay, is that clear? Okay, good. Next question. Shall I go to the next question? Okay, 24th. What do you think the answer is? 24th. 24th.
D, option D.
ऑप्शन डी रीजन 1. क्यों रीजन 1 पास में लग रहे इसकी वजह से क्या? That's not the answer. The answer is region 2. Okay, the answer is region 2. It is the hottest. And यहाँ पे आपको different regions के लिए Bunsen burner में there is some categorization. Region 1 is called as preheating zone. Region 1 is called as preheating zone. Region 2 जो है, it is called as primary combustion zone, or it is the hottest zone. यहाँ पे ही combustion होता है. Okay, it is the primary combustion zone. यहाँ पे space में मिल रहे हैं, इस साइड लिखता हूँ. Region 2 is primary combustion zone. Okay, region 3 जो है, it is called as internal zone. Internal zone. Region 4 जो है, मतलब इसके ऊपर the boundary. Region 4 जो है, it is called as secondary combustion zone. Secondary combustion zone. Is that clear? You need to remember these things. The hottest region is region 2, which is also called as primary combustion zone. Region 1 जो है, that is called as preheating zone. Okay. Let's go to question number 26. 26 answer.
D option C.
Lithium जो है, it can form only oxide. Sodium जो है, it can form peroxide in excess of O2. Potassium जो है, it can form superoxide. So option C. Good. And in case of group 2 में क्या है? Only strontium and barium, they can form peroxide, but rest all of them will be forming oxides. Remember? Okay. Yeah, question number 27. The highest first ionization energy is for answer?
Sodium.
Sodium. Okay. If you are saying sodium has the highest first ionization energy, इसका मतलब scandium has to be a stronger metal when compared to sodium. है कि नहीं? Scandium जो है वो d block element है, जिनका ionization energy कम रहेगा, obviously that will be a stronger metal. Sodium, potassium, rubidium में तो down the group the ionization energy decreases, इसलिए metallic strength increases. ठीक है. And यहाँ पे scandium भी एक दिया है. If you are saying sodium has the highest ionization energy, scandium has to be more active, even more active metal than sodium. But is scandium an active metal when compared to sodium? No. Okay. Highest ionization energy is for scandium because it is a d block element. Okay. You may feel that sodium में 1:2:2p6 3s1 है ना, यहाँ पे 3s1 है. Scandium में 1:2:2p6 3:3p6 4:2 3d1. It is 4:3d1. So you may feel यहाँ पे fourth shell से हटा रहा हूँ, यहाँ पे third shell से हटा रहा हूँ. So this should be having the greater ionization energy. ऐसा कुछ सोच के ऐसा आप लोग बोला होगा, but it is scandium. The reason is you are removing an electron here is from the 4s. Agreed? From the 4s, and it is completely filled. S जो है यहाँ पे completely filled हुआ है. Moreover, scandium में Z star थोड़ा ज़्यादा हो जाएगा because of presence of electron in the D, which has poor shielding effect. Okay. और ये सब भी मत सोचो. Directly scandium is a weaker metal, so it will be having a greater ionization energy. Is that clear?
Answer.
Okay. Question number 30. Question number 30. A sodium salt of an unknown ion, anion, when treated with MgCl2, gives white precipitate only on boiling. Gives white precipitate only on boiling. The anion is. What is the white precipitate? यहाँ पे आपको precipitate क्या?
MgCO3.
Very good. The precipitate has to be MgCO3. So MgCO3 जो भी मिला है boiling करने के बाद मिला है. MgCO3. The white precipitate is nothing but MgCO3. अगर if you are taking Na2CO3, Na2CO3 plus MgCl2 आपको displacement होकर MgCO3 मिल जाएगा. Without boiling only you will get that white precipitate. If you are taking sodium bicarbonate, NaHCO3, NaHCO3, if it is reacting with MgCl2, you will be forming magnesium bicarbonate. Magnesium bicarbonate is soluble. All bicarbonates are soluble. Whenever you are heating them, the bicarbonate will be converting into carbonate and CO2. Remember? So, इसको heat करने से, boil करने से ही आपको magnesium carbonate आएगा. So, answer has to be B. You may be confused between C and B, but C के साथ पहले से ही मिल जाएगा आपको. No need to heat that. Boil, they are saying only on boiling. So, it has to be bicarbonate. Is that clear? Okay. All carbonates are in general white PPTs. Okay. Calcium carbonate white है. Milky white. Whenever it is treated with excess of CO2, it will be converting into bicarbonate and it is soluble. ऐसा कुछ बात किया हमने, which is test of CO2. Similarly, Brita water के साथ भी वही होगा. Barium carbonate is also white. If you are passing excess of CO2, it will be converting into barium bicarbonate, which is soluble. Is that clear? Is that clear? Brita water या lime water दोनों same ही reactions है. Brita water मतलब BaOH twice. Lime water मतलब CaOH twice. Any doubt, anyone? Okay. Question number 33. Which of the following do not contain peroxide ions?
AN.
Option A, because this is strontium peroxide. वो कैसे हटा निकालना है? Sr plus 2 है, being a group 2 element, so it will be O2 2 minus. Barium plus 2 है, यहाँ पे भी आपको O2 2 minus रहेगा. यहाँ पे H2O2 में हाइड्रोजन का +1 ऑक्सीडेशन स्टेट है, यहाँ पे O2 2 minus. O2 2 minus is nothing but peroxide. Agreed? So PbO2 जो है, it is Pb plus 4 and oxygen is in -2 oxygen state. आपको PbO मतलब Pb plus 2 oxygen state में है. PbO2 में आपको Pb is in +4 oxidation state because it is group 14 element. Group 14 element में maximum oxygen state it can be +4. Agreed? So PbO2 में Pb +4 और O2 -4 है. Okay, O2 -4. So it is not a peroxide, it is simply an oxide. So option A. Good. Okay, take some time and quickly solve these questions. In this, you also have more than one option questions. Take some time and solve these questions. Take 10 minutes, solve, and let me know once you are done. Question number 34. The metallic luster exhibited by sodium metal is explained by. What is the reason for that?
Lose electrons.
So it is because of oscillation of loose electrons. Any doubt? Okay. Nitrogen dioxide cannot be obtained by heating. All nitrates, in general, when you heat them, they will be giving you NO2 plus O2. All nitrates along with the oxide, except from group 1. And group 1 में lithium nitrate having diagonal relationship with magnesium, it also gives NO2 and O2. So group 1 में यहाँ पे potassium nitrate दिया है, it won't be giving you NO2 and O2, it will be giving you nitrite, KNO2 plus O2. If I am heating that at a greater temperature, that KNO2 further splits into oxide K2O plus N2. ओके, सो ग्रेटर टेम्परेचर पे आपको N2O2 प्लस ऑक्साइड मिलेगा, NO2 तो नहीं मिल रहा है. सो द आंसर इज ऑप्शन ए. Any doubt? Okay. The oxide that gives H2O2 on treatment with dilute acid is
सोडियम पेरोक्साइड.
Sodium.
हाँ, सोडियम पेरोक्साइड Na2O2. यहाँ पे PbO2 जो है, फर्स्ट ऑफ ऑल दिस इज नॉट अ पेरोक्साइड, दिस इज एन ऑक्साइड. MnO2, this is also not a peroxide, this is also an oxide. TiO2 similarly, this is also not a peroxide, this is an oxide. So Na2O2 जो है, being a peroxide salt, whenever I'm adding an acid, Na positive will be replaced by H positive to form H2O2. So the answer is only B. Chlorine salt, Na2SO4 dot 10 H2O. A solution of sodium metal in liquid ammonia is strongly reducing. This is due to
Solvated electrons.
solvated electrons
Solvated electrodes.
or ammoniated electrons. Okay. 42. The pair of reagents that yield paramagnetic subspecies are. Option A. What are the answers? आप लोग ने क्या कहा, क्या टिक किया?
B option.
A and B.
A or
It is more than one option. First of all, it is more than one option. So एक ही option तो मत टिक करो आप लोग, मतलब in general ज्यादा ही रहेंगे. A is also right option because whenever sodium is dissolved, you are getting an electron. Single electron is nothing but a paramagnetic one. Whenever you are having paired electrons, it will be diamagnetic. एक electron रहा तो it will be paramagnetic. So A is also a right option. Sodium in excess of O2, what do we get? You will be getting peroxide. Sorry, superoxide KO2. KO2 is K positive and O2 minus. O2 minus जो है, if you are applying MOT for this, it will be paramagnetic. Moreover, O2 minus में आपको 17 electrons है. O2 मतलब 16, O2 minus मतलब 17. If you are having odd electrons, obviously it will be paramagnetic. Agreed? Any doubt, anyone? So B is also an option. C देखते हैं. Copper with dilute HNO3. Everyone, as of now, ये वाला particular question जो है या ये जो reaction है हमने देखा नहीं है, but these are some important set of reactions in P block of 12th. अभी आपको बता रहा हूँ. Try to remember that. Once again, we will be encountering the same reaction in that particular chapter. For now, remember this. Ag, Hg, Cu, Pb. You can remember this as आगे होंगे क्यूट पंजाबी, वैसे याद रखो, आगे होंगे क्यूट पंजाबी. And being Maharashtrians, you will say no. You will feel Maharashtra people ज़्यादा cute है. So the answer is NO. There will be no मतलब वहाँ पे there will be liberation of NO. Okay. Nitrogen monoxide. Is that clear? How to remember this? आगे होंगे क्यूट पंजाबी, no. Is that clear? Okay. All of these, whenever they are reacted with dilute HNO3. Dilute HNO3. What is the product obtained? NO. Is NO paramagnetic, diamagnetic? Nitrogen में आपको 7 electrons, oxygen में 8 electrons, total 15. Odd number of electrons, obviously paramagnetic. Agreed? So C is also right option. Is that clear? C is also right option. यहाँ पे और एक भी याद रख सकते हो, जैसे आगे होंगे क्यूट पंजाबी है. There are 2 other D block elements. If you observe, all these are D block metals. Ag, Hg, Cu, Pb, D block. Okay. Fazan, Fezn. Fazan हंसाता है. Laughing gas is N2O. Okay. N2O is laughing gas. ऐसा याद रखो. फजान रूल्स है ना. ओके, इसलिए फजान हंसाता है, वैसा एक स्टेटमेंट. फजान हंसाता है मतलब Fe और Zn with dilute HNO3. It will be giving you N2O, which is laughing gas. N2O is called as laughing gas. NO, N2O. आगे होंगे क्यूट पंजाबी, नो. फजान हंसाता है, याद होगा. Okay, these are important, very, very important reactions. We will be seeing again in the chapter of P block. Okay, so abhi yaad rakh lo, it will be beneficial. These two set. Is that clear? Okay, so C is also right option. D जो है, ये जो particular D का reaction जो है, it is a preparation method for H2O2. ये हाइड्रोजन उसमें देखेंगे. अभी के लिए इतना याद रखो, it is a preparation method for H2O2. H2O2 is peroxide. Peroxide मतलब आपको O2 2 minus है. O2 2 minus is diamagnetic. O2 minus is paramagnetic. O2 2 minus is diamagnetic. So D is not the right option. Is that clear? Easy. If you know the information, it is easy. They are straightforward. आपको A और B already पता चला. C is also a very important reaction in P block. So वो भी आपको आगे समझा ही दूंगा. Okay. So this is also an easy option. D, hydrogen में देखेंगे preparation method of H2O2. So once you know all of this, it is easy to score the question. Is that clear? 43 तो आप लोग कर लिया होगा. The compounds formed upon combustion of sodium metal in excess of A and R.
A and B.
An oxide as well as peroxide. Okay. So Na2O2 and Na2O. Can we get superoxide?
No.
No.
No. ठीक है. ठीक है. Next, 44. Sodium nitrate above 800 degrees. Answer?
A and B.
A and B.
ABD.
Answer is ABD. A, B and D. वो नाइट्राइट जो है ऑक्साइड में ही कन्वर्ट होगा ना. Initially what is the reaction? Na जो है और सोडियम नाइट्रेट ना, NaNO3 जो है, whenever you are heating it, first it converts into NaNO2 plus O2 nitrite. This on further heating, it converts into Na2O plus N2. So overall आपको प्रोडक्ट्स क्या मिला? यहाँ पे ऑलरेडी O2 है, यहाँ पे N2 है, यहाँ पे Na2O है. Okay, O2, N2, Na2O. Answer is ABD. Okay, question number 45. Highly pure dilute solution of sodium in liquid ammonia. Yeah. Answer?
AB.
AB. AB.
Answer?
A.
Shows
AB.
blue. ये तो पता है हमें. Exhibits electrical conductivity. ये भी पता है. Produce sodium amide. ये गलत है. Unless and until you are heating it. अभी यहाँ पे तो dilute solution हो गया ऊपर से. Unless and until you put hot metal, you will not get sodamide. Okay. So C नहीं बनेगा, sodamide नहीं मिला तो hydrogen gas भी नहीं मिलेगा. So answer is only A and B. Any doubt? Okay. 47, last question. Sodium sulfate is soluble in water, whereas barium sulfate is sparingly soluble because sodium sulfate soluble हो रहा है मतलब उसका hydration energy dominant होना चाहिए. So hydration of sodium sulfate is more than its lattice energy. सही है. यहाँ पे the lattice energy of barium sulfate is more, तभी तो insoluble हो रहा है. Down the group, yeah, tell me. Anyone any doubt? Okay. Down the group, the lattice energy will be decreasing at a slower rate because of achievement of packing efficiency in case of larger anions. As a result, barium sulfate is becoming insoluble. So lattice energy जो है, it is becoming greater when compared to hydration energy. इसलिए वो insoluble है. Any doubt? C option, lattice energy has no role. गलत है. Hydration energy of sodium sulfate is less than lattice energy. नहीं है, ज़्यादा होना चाहिए तभी तो soluble होगा. Any doubt, anyone?
No, sir.
Okay. So these are the questions of S block. S block में group 1 से ही किया है हमने. If you observe, there are no questions of group 2. So I will add questions of group 2 and I will share that particular part. Try to solve those questions. Tomorrow we will directly discuss those questions. Okay. Notes में I will add those. I will be sharing the notes, adding the questions of group 2. Okay. Everyone go through all the questions of group 2. Group 2 मतलब obviously आपको उसमें हाइड्रोजन तो नहीं रहेगा, only group 2 questions दिखेगा. Okay, so please solve all those questions. We will discuss tomorrow. Now we will start P block. जैसा हमने एस ब्लॉक में पढ़ाई किया है ना, initial we will be seeing some properties, general properties, then we will be seeing some compounds, important compounds. We will follow the similar pattern. First we will be seeing the general properties of group 13, then we will be going to some important compounds of group 13, then we will see the general properties of group 14. Okay, ये P block में केवल हम group 13 और 14 ही पढ़ने वाले हैं. 11th में हमको group 13 और 14 है. In 12th you have 15, 16, 17, 18. Okay. Okay. चलो स्टार्ट करते हैं. P block, in general P block has non-metals in general. Okay, but there are some metals as well as metalloids. Down the group, metallic nature increases and non-metallic nature decreases. So when you go down the group, you can encounter some metals. Whenever you are converting a non-metallic character to a metallic character, बीच में आपको metalloids भी रहेंगे. Okay, so यहाँ पे non-metals लिखा है. Non-metals are कार्बन, नाइट्रोजन, फॉस्फोरस, ऑक्सीजन. ये सारे पी ब्लॉक को, सारे पी ब्लॉक में जो भी नॉन मेटल्स है उनके बारे में लिखा है. ओके, एंड और एल्स आपको पहले से ही ये इंफॉर्मेशन दिया है ना. वंस अगेन लेट अस फॉर्म दैट एंटर पी ब्लॉक. प्लीज टेल मी एंटर पी ब्लॉक. यू हैव बोरॉन, कार्बन, सॉरी, बोरॉन, एल्यूमिनियम, गैलियम, इंडियम, thallium, then you have carbon, silicon, germanium, tin or lead. After this, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium. Then you have fluorine, chlorine, bromine, iodine, astatine. Okay, astatine के बारे में in general इसके बारे में डिस्कस नहीं करेंगे. Being radioactive, similarly polonium is also radioactive. देख अभी के लिए मार्क किया है. इनमें हमने मेटलॉइड्स के बारे में मार्क किया. If you remember, हमने ऐसा कुछ मार्क किया. बोरॉन को मार्क किया एंड देन बाद में इन दोनों को मार्क किया. रिमेंबर, सिलिकॉन, जर्मेनियम. देन वी हैव मार्क्ड दीस टू. देन वी हैव मार्क्ड दीस टू. ओके, सिमिलरली एस्टाइन, यहाँ पे एस्टाइन जो है दैट इज आल्सो कंसिडर्ड एज मेटलॉइड. इफ यू ऑब्जर्व हियर, देखो सेमी मेटल्स और मेटलॉइड्स. सेमी मेटल्स और मेटलॉइड्स आर नथिंग बट बोरॉन, सिलिकॉन, जर्मेनियम, arsenic, antimony, tellurium, polonium, and astatine. Okay, so इनके अबो जो भी है, all of them will be non-metals. So carbon, nitrogen, phosphorus, oxygen, sulfur, selenium. Okay, fluorine, chlorine, bromine, iodine. Then आपको ये तो noble gases तो आपको non-metals ही रहेंगे. Any doubt? Helium, neon, argon, krypton, xenon, radon, oganesson. Okay, radon के नीचे वाला. Is that clear? यहाँ पे ये भी मार्क कर लेते, फिर वो छोड़ना क्यों है. हीलियम, हीलियम ऊपर रहेगा. नियॉन, आर्गन, क्रिप्टन, xenon, रेडॉन. ओके, एंड यहाँ पे और एक इंपॉर्टेंट इंफॉर्मेशन दिया है. ओनली सॉलिड्स आर कार्बन, कार्बन, नाइट्रोजन, सॉरी, कार्बन, phosphorus, sulfur, selenium, and iodine. Only these are solids. Carbon, phosphorus, sulfur, selenium, and iodine. Okay. And you have bromine as liquid. Br2 is liquid. Rest all of them are gases. Is that clear? Solids are, हमको पता ही है. Carbon is a solid. Phosphorus, sulfur, selenium is also solid. Iodine is also solid. Iodine भी आपको पता ही है. Iodine is a solid at room temperature. So selenium आप अलग से याद रखो. Selenium is also solid. Okay, semi metals mark किया है. Rest all of them are more and more metallic when compared to the non-metallic nature. Okay, because these are metalloids ना, यहाँ पे इसके बाद transition हो जाएगा. They will be having metallic character. Okay, मेटल्स में अल्यूमिनियम, इनफैक्ट अल्यूमिनियम के लिए भी अल्यूमिनियम ऑक्साइड और अल्यूमिनियम हाइड्रोक्साइड के लिए एम्फोट्रिक नेचर है, मतलब इट कैन रिएक्ट बोथ विद एसिड एज वेल एज बेस. ओके, बट इनके मेटलिक प्रॉपर्टीज आर मोर डोमिनेंट व्हेन कंपेयर टू नॉन मेटलिक प्रॉपर्टीज, इसलिए मेटल्स में कंसीडर कर रहा हूँ. अल्यूमिनियम, गैलियम, इंडियम, थैलियम, टिन एंड लेड, बिस्मथ. उसके बाद ये जो एलिमेंट्स है यहाँ पे रहेंगे. नो नीड टू रिमेंबर these elements. These are the elements which are important. If you want to make note of this, you can also make note of this. Okay. पीरियोडिक टेबल में हमने नीचे वाला जो पीरियड है इनके बारे में मार्क नहीं किया, ये वाला पीरियड. ओके, विच इज द 7th पीरियड. ओके, 7th पीरियड एलिमेंट्स को सारे मार्क नहीं किया है हमने. या दिस इज 2nd पीरियड, 3rd पीरियड, 4th, 5th, 6th एंड 7th पीरियड. 7th पीरियड एलिमेंट्स हमने मार्क नहीं किया है. You can also remember these elements. These belong to 7th period. Is that clear? Okay. एक बार ये याद हो गया आपको, इसके बिलो आर मेटल्स, इसके अबव आर नॉन मेटल्स, इतना ही. इसको भी मार्क करना आसान है. Any doubt, anyone? Easy? Okay. Let's go to group 13, boron family. Boron is typically considered as a non-metal. उसको metalloid में, semi-metal में मार्क किया है, but इसका non-metallic properties are more dominant when compared to metallic properties. Okay, it is a metalloid or semi-metal, but its non-metallic properties are dominant when compared to metallic properties. Is that clear? Okay. It is extremely hard. In general, अगर non-metal है तो it has to be soft. Okay. But in this case, it is extremely hard because of the chain structure of boron, extremely hard, as well as it is a black solid. Rest all of them are metals. Rest all of them are metals, but they show many chemical properties similar to that of boron, hence all of them belong to the same family, obviously. Okay. Rest all of them are metals, only boron is a non-metal or semi-metal. Physical nature. It exists in 2 allotropic forms. Boron exists as alpha and beta, out of which beta is more stable. Gallium, indium or thallium. Gallium, indium or thallium. They are soft metals and they exist as, जो gallium है, it can exist as a diatomic molecule, Ca2. Okay. Aluminum is also a metal. And down the group, as the metallic bond strength decreases, the softness is increasing. Aluminum is strong, but बाकी सब जो है, they are soft metals. The reason is the metallic bond strength decreases down the group. Is that clear? And gallium can exist in diatomic form, which is Ga2. Okay. Melting and boiling point में यहाँ पे कुछ चीजें आपको याद रखना होगा. Boron has the highest melting point because of its giant covalent structure. Okay, highest melting point due to its giant covalent polymer structure in solid as well as liquid states. It exists as a polymer in liquid as well as solid states. As a result, it is having the highest melting point. And down the group till gallium, the melting point is decreasing. And later that, after gallium, the melting point is increasing. Okay, or else gallium has the minimum melting point. Gallium has the minimum melting point, but in case of boiling point, it has some higher boiling point due to यहाँ पे एक मिनट, यहाँ पे boiling point का overall order जो है, boiling point decreases down the group. Boiling point general order यहाँ पे melting point के लिए यहाँ पे mark किया है, but जो boiling point है, you don't have any variation. Boiling point decreases as metallic bond strength decreases, boiling point decreases. But in case of melting point till gallium it is decreasing. After gallium it is again increasing. Okay, ये जो gallium है, even though it has the lowest melting point, it has some good amount of boiling point, which is 2676, which is very, very high. Because of this property, it is used in high temperature thermometry. It is used in thermometers which are used at very, very high temperatures. Okay, you can remember this as very important use of gallium. Is that clear? Boiling point order जो है, down the group it decreases, there is no exception. But for melting point, till gallium it is decreasing. From gallium, it is again increasing. Is that clear? So यहाँ पे आप लोग ऐसा कुछ लिख सकते हैं, boron greater than aluminium greater than gallium. This is melting point order. Less than indium less than thallium. Is it clear? Okay. Next, atomic radii. Group 13 elements के atomic radii में हमने एक exception देखा है periodic properties में, if you remember. Okay. What is that exception? If you write the configuration of gallium, it is 4s2 3d10 4p1 4s2 3d10 4p1. यहाँ पे चाहो तो ऐसा लिख सकते हैं आप लोग 4s2 3d10 4p1. And if you write the electronic configuration of aluminium, aluminium is 3s2 3p1. Based on the number of shells, what can you comment on size of aluminium and gallium? Aluminium has to be smaller in size when compared to gallium because aluminium is having 3 outermost shell as 3, gallium is having the outermost shell as 4. But based on Z star, in case of gallium, just before this 4th shell, you have filled 10 electrons in the D subshell. The D subshell has very, very poor shielding effect. If you are having very poor shielding effect, what happens to Z star? It increases, everyone, or else Z star of gallium is greater than Z star of aluminium. Based on Z star हमने क्या बात किया तब? Aluminium का radius जो है, it has to be greater when compared to gallium's radius because Z star of gallium is greater than Z star of aluminium. And based on number of shells, we have discussed aluminium का radius has to be lesser when compared to gallium's radius. Agreed? And हमने ऐसा कुछ ending में ये conclude किया है, both of these factors counterbalance and atomic radius of gallium or aluminium becomes almost similar. याद है ऐसा कुछ लिखा हमने? Okay. Periodic properties में ऐसा कुछ लिखा है, boron less than aluminium almost equal to gallium less than indium less than thallium, ये लिखा है. But exact values देखा तो in general if the option says that both of them are equal, वो सही है. But if they are asking about the exact order, gallium is slightly lesser than aluminium. Because of greater Z star, gallium becomes slightly lesser than aluminium. So इसलिए आपको order यहाँ पे लिखा, boron less than, gallium less than, aluminium less than, indium less than thallium. Is that clear? Once again, I'm repeating this. In case of gallium, you are having 4 shells. In case of aluminium, you are having 3 shells. As you are having 4 shells, we expect the radius of gallium to be higher when compared to the radius of aluminium. Okay. But the Z, if you are comparing the Z star of gallium is significantly higher. Why is it significantly higher? Because just before that, you have filled 10 electrons in the 3D subshell, which has very poor shielding power. If the shielding power is less, what happens to Z star? Significantly increases. If Z star is more, the radius is expected to be lesser in case of gallium when compared to aluminium. Both of these factors, यहाँ पे radius ज़्यादा होना चाहिए gallium का, यहाँ पे radius of gallium कम होना चाहिए. Both of these factors counterbalance, and we concluded in periodic properties the radius of gallium is almost equal to aluminium. यही है, अभी भी यही है. But if you want the exact order, gallium का radius slightly कम रहेगा when compared to aluminium. इसलिए ये order लिखा है. Both the orders are right. It depends upon the question. Question में आप लोग को कैसे पूछा जा रहा है देखो. If you are given both the orders, then obviously mark this order only because this is more appropriate. Is that clear? If you are not given this order, then mark this. Okay, ionization energy. Ionization energy में we have seen the oscillating trend. Aluminium और gallium दोनों का radius almost same हो गया. But Z star of gallium is greater than Z star of aluminium. As a result, you will be applying more and more energy to remove the electron. Down the group, the general trend is ionization energy has to decrease. So boron is greater than aluminium, but aluminium is becoming lesser than gallium. What is the reason for that? Because of the greater Z star in gallium and equal size. Okay. Next, gallium is becoming greater than indium, TK, but indium again becomes lesser than thallium. What is the reason for that? In case of thallium, you will be filling 4f subshell. If you are filling 4f subshell, what is happening to the Z star of thallium?
Decrease.
Z star decrease होगा, 4f subshell
Increase.
increases. अगर Z star बढ़ा तो फिर से उसमें ionization energy ज़्यादा रहेगा. I hope everyone of you remember this. We have written this as oscillating trend in periodic properties also. Is that clear? Okay. Same is the order for the second and third ionization energy. Okay. Oxidation states. Oxidation states, the general electronic configuration of group 13 is NS2NP1. If only p electrons are participating in bonding, you will be having a +1 oxidation state. If p as well as s, if all the 3 electrons are participating in bonding, you will be having a +3 oxidation state. And हमने again periodic properties में ही पढ़ा, inert pair effect में, down the group, the stability of lower oxidation states increase. Down the group, stability of lower oxidation states increases, and stability of higher oxidation states decreases. Remember, stability of higher oxidation states decreases. याद है? So इस particular group में, if I am comparing the higher oxidation state, down the group the stability of higher oxidation states decreases. इसलिए B3 positive greater than, down the group it is decreasing. Al3 positive greater than, gallium 3 positive greater than, indium 3 positive greater than, thallium 3 positive. And यहाँ पे the stability of lower oxidation states is increasing. इसलिए B positive less than, Al positive less than, gallium positive less than, indium positive less than, thallium positive. Everyone please put your video on. And what is the reason for that? Because of inert pair effect. Inert pair effect मतलब suppose thallium में आप लोग +3 बना लो, +3 बनाने के बाद because of the greater Z star in case in thallium, why do we have greater Z star? That is because of presence of 14 electrons in the 4f subshell. 14 electrons in 4f subshell and 10 electrons in 3d subshell. Z star significantly increases. Because of the greater Z star, you cannot remove 3 electrons. एक ही इलेक्ट्रॉन रिमूव कर पाएंगे थैलियम में. एवरीवन रिमेंबर दिस. थैलियम से और थैलियम के कॉन्फ़िगरेशन में आपको 4f और 3d दिखेंगे. 4f और 3d के शील्डिंग पावर is very poor.
Yes, sir.
Because of poor shielding, what happens to Z star? Increases significantly. Because of the increased Z star, I can never remove 3 electrons. एक ही इलेक्ट्रॉन रिमूव कर पाऊंगा. इसलिए thallium +1 is more stable than thallium +3. और +3 भी किया है आप लोग. It will immediately accept 2 electrons because of its greater Z star. Is that clear? Okay. बाकी सब में very important. बाकी सब में इनके higher oxidation state ज्यादा stable होगा when compared to lower oxidation state. मतलब B+3 is more stable than +1, Al +3 is more stable than +1, so on. Indium +3 is more stable than +1. Only in case of the last element, the +1 oxidation state becomes more stable than +3. So यहाँ पे यही लिखा, boron जो है it has +3 oxidation state in all of its compounds because इसका +3 ज्यादा stable है. बाकी aluminium, gallium, indium जो है +3 is more stable than +1, but they are able to have that +1 oxidation state. Okay. Boron जो है it is only significantly having +3 in all of its compounds. बाकी सब जो है they are able to have +3 as well as +1, but +3 is more stable. Is that clear? Okay. As +3 is more stable, if you are having gallium +1, it disproportionates in aqueous solution. मतलब क्या है? Gallium यहाँ पे +1 है. Disproportionation मतलब the same element undergoing oxidation as well as reduction. gallium +1 being less stable when compared to gallium +3, it is spontaneously converting into +3. Okay, it is losing electron, converting into +3. The lost electrons are gained by another +1 oxidation state to convert into 0 oxidation state. Very, very important. Gallium or indium जो है, as their +3 oxidation states are more stable than +1, whenever you are leaving +1 oxidation states in the solution, they will disproportionate spontaneously. This reaction will happen on its own. समझ में आया? Okay. And the thallium +1 compounds जो है, they resemble most of the properties similar to that of alkali metal compounds. जैसे TLOH, because this has become highly metallic. TLOH is similar to that of NaOH, so it is strongly alkaline, just like NaOH. Alkaline में sulfates जो है, alkaline or alkali sulfates, apart from lithium sulfate, rest all others can form double salts, which are called as alums. Similarly, thallium +1 or thallium sulfate जो है, it can also form a double salt. Okay, and thallium +3 can act as very good oxidizing agent because +3 immediately converts into +1. यहाँ पे +3 है, यहाँ पे +1 है. It has accepted 2 electrons. Oxidizing agent मतलब खुद reduce होगा. Why is it accepting electrons? Because its +1 is more stable than +3. Any doubt? Anyone? Any doubt? Okay.
No, sir.
Okay. Boron के +3 ionic compound, +3 are mostly covalent compounds. They won't be having ionic compounds because boron is considered as typical non-metal. उसका non-metallic nature is greater when compared to the metallic nature. Okay, even though it is metalloid, उसका non-metallic nature ज़्यादा है. So boron +3 ionic compounds are not known. Only form covalent compounds. They won't be forming ionic compounds. They will be forming covalent compounds. Is that clear? This is also an important statement. बाद में anomalous behavior of boron भी देखेंगे. सारे groups के पहला member जो है, they will be having some exceptional behaviors. So उनके बारे में हमको पढ़ना ही है. Boron, just like beryllium and lithium, it is forming significantly covalent compounds. कोई भी period में, यहाँ पे वही लिखा, lower oxidation state will be period 6 and 7 मतलब thallium वाला हो गया. Thallium is period 6, उसके नीचे you will be having another element period 7 में. उनके lower oxidation states are more stable than higher oxidation states, but rest all other periods, period 4, 5, or you can take 2 and 3 also, the lower oxidation state will be less stable when compared to the higher oxidation state. Is that clear? ये वही लिखा, down the group the stability of lower oxidation state increases and the stability of higher oxidation state decreases. And for the last element मतलब period 6 or 7 के, इनके lower oxidation states are more stable when compared to the higher oxidation states. And उनके above वाला period में their higher oxidation states are more stable when compared to the lower oxidation states. Is that clear? Last point, oxidation state में gallium जो है, it appears to have +2 oxidation state in GaCl2 क्योंकि Cl का -1 रहता है, Ga का +2 रहता है ना तब. But actual में वो +2 नहीं है, it is +3 only. Reason, GaCl2 actual structure is GaCl4. You are having a coordination compound here. This is the coordination compound. Its empirical formula is GaCl2. आपको Ga2 है, Cl4 है. Empirical formula is GaCl2. Hence it appears to have +2. But actual में क्या है? It is +3 and +1. यहाँ पे बाहर ये +1 है. Here it is having +1 oxidation state. Here it has to be +3. क्लोरीन 4 है, इसलिए नेट में आपको -4 रहेगा. और इसके ऊपर आपको नेट में -1 रहेगा. +1 -1 बैलेंस हुआ. Understood?
Yes, sir.
So group 13 elements जो है, they can never show any other oxidation state other than +1 and +3. And उनमें भी उस stability के बारे में हमने discuss किया. Only for group period 6 elements, the lower oxidation state becomes more stable than higher oxidation state. But rest all other elements will be having higher oxidation state more stable than lower oxidation state. Is that clear? Is that clear, everyone?
Yes, sir.
यहाँ तक आप लोग रिवाइज करो. Tomorrow again we will solve some questions from group 2. After that we will be continuing with this chapter. I'll post the questions. So please solve them before coming to the lecture only. Thank you everyone.